Hello, everyone. Welcome and thank you for joining this webinar on using Git and parallel development. Just some quick housekeeping before we get started. So there's a chat box in Zoom you can put your questions into. I'll try to respond on the fly, but if I don't, I'll come back to them at the end just for a Q&A section at the end. Okay, great. Maybe we'll get started. So just a little bit about me to begin with. So my name is Yegor. I've been a managing consultant here at Altis for about 2.5 years. And I've been in the BI and data engineering space for, I'd say, almost 10 years now, I believe. And yeah, and this topic will be about parallel development using Git. So to begin with, just the agenda for this session. So it's really 3 sections. One is really introducing you to Git and the Git workflow. The second section will be around just providing a basic demo of how to use Git, both using Visual Studio Code via the UI and also using command line interface. So I think 1 and 2 is really to make sure to bring everyone on the journey, even if you haven't used Git before, you're not very familiar with it. And then the last section will be kind of covering some of the more kind of interesting and advanced concepts. So things like branching strategies, naming conventions, and resolving any kind of merge conflicts you run into. Okay. So I guess what is Git? Maybe it's probably the best way to start things off. So the way I would kind of define Git is it's a tool for repository lineage tracking, distributed version control and development, continuous integration, using a command line interface. So that's kind of understandably a bit of a mouthful, but let me kind of walk through each of these step by step. So kind of looking at the picture on the left-hand side here. So what Git refers to as a repository is essentially your full code base, or kind of a portion of it that you want to put on a particular repository. That code base or repository goes through changes, and fundamentally Git is about tracking those changes over time. So the way that Git does this is through a lineage of what's called commits, which trace across a particular branch. So each commit, think of each commit as a set of changes. It may be one change, it may be multiple changes to multiple files, but ultimately has to be at least one change to the previous state of your previous commit or the previous state of your code base. The other kind of key concept is branches. You'll see kind of there's a main line here, which is referred to as your main or your master branch, but then there's these offshoots, this purple and this blue, which are your feature branches. So one of the values that kind of Git brings is you can have multiple developments or multiple kind of alternative truths of your code base at a given point in time. So you might have multiple features you're developing for your data platform. And each of those might have several commits that go through. And at some point, you'll go back through and merge it back into your main or master branch. So when I say merge, it's about integrating those changes in a way that's combining the 2 branches together into a kind of a common main branch. So I'll talk more about how this integration works at a later point in time, but this is just kind of more at a high level. And this really touches on the whole continuous integration aspect of Git as well. So one of the nice things that Git does is it will flag for you any kind of merge conflicts. It won't resolve them for you, but it will highlight them and make it easy for you to see, well, this incoming change that you have has a conflict, and therefore you need to resolve it and identify which is the correct version of the code that you want to actually end up with as your final step. So that's kind of the left-hand side of this slide. The right-hand side is really the distributed version control and development aspect of it. So the way that Git is usually set up is you'll have what's called a remote server or remote repository. So this is sometimes referred to as origin as well. You'll find in Git there's a lot of use of terminology, which takes a little bit of time to get used to. And this is usually something like GitHub, which is probably the most common, or Azure DevOps or GitLab. Think of this as kind of your hosted master truth of your repository. But then the process that Git uses for developers to make changes is you effectively take a copy of the full repository. Let's say you clone it to your local computer. You make changes on it. So you make commits, including, let's say, adding a new feature branch or adding commits to an existing feature branch. And then you push that feature back to your central repository. So I guess one key point to highlight here is you can push branch changes, but generally you're not pushing directly to your main or master branch. What's done in that situation is what's called a pull request, which I've highlighted here. I'll get into that a little bit more a little bit later, but essentially it's a way of better controlling what changes actually get put onto this main or master branch, because you want to be careful about committing or making changes that would otherwise break your code. Okay, and I guess the last part of it is Git is command line based. So it's something that if you want to use at a very fundamental level, you have to write commands in, a command prompt, command prompt in your terminal. But there are various UI tools which help make things a lot easier, both of which I'll kind of show later on. Okay, so great. So, maybe hopefully you have a basic understanding of what Git is, but I guess why should you care? Why? Because let's be honest, this is probably not the most exciting topic in the world when describing it. So let me make the case something that's really worth mastering. So in terms of software engineering, I think it's almost universally used. And I would say if you're working on any kind of modern data project or data platform, especially in the cloud, you're almost certainly also going to be using Git. I think it's pretty much the dominant version control tool. And it just provides a lot of benefits that not having it would otherwise deprive you of. So if you've used kind of previous version control tools, so maybe you've used Team Foundation Services and Visual Studio, or you've used Subversion, they work a little bit differently in that you're actually locking the file that you're editing. So you can kind of think of those older tools as having a more pessimistic approach when it comes to version control, in that you lock a file, you modify it, you push your changes back, and then you unlock it for other developers to use. Git is almost the opposite of that, in that it takes an optimistic approach where you take a copy of whatever the state is, you don't actually lock it, and then you figure out how you integrate it at a later point in time when you actually want to integrate those changes. Another huge benefit of Git is you can release in any order. So, and what I mean by release, so you can release different changes to your code base in any order. I think anybody who's worked on a data platform knows that the business will often change their minds around timeframes or whether they even want to release a particular feature or not. Git provides you a way of kind of ordering it in any way that you like. As mentioned before, it's very good for identifying conflicts. So you'll still have to resolve them, but it will flag those for you so you don't, I guess, override any changes effectively. And the fact that it has a lineage means it makes it really easy to track who or when a change is being made, and also then find a given bug or issue and roll back to that if you need to. I guess I would also just add to this as well, if you're interested in data engineering or DevOps or data science, again, I would say that you really have to have a very deep understanding of Git, especially if you're interested in DevOps. So from that point of view, I think it's just a good tool to have in your toolbox for career development. So just a really quick slide on installation. I won't actually go through this, but just to highlight a few things. So you need to download and install it. There's one option it gives you during installation around what default editor you want to use. I highly recommend either Visual Studio Code or Nano. By default, it will select Vim. In short, Vim will kind of force you to memorize certain hotkeys. And unless you know what you're doing there, I would advise not to use it. Another thing you'll need to do is to set up some configs to basically identify who you are to Git. So when you make a commit, there'll be a name against it and there'll be an email address against it as well. So you'll just need to run these commands when you first install Git. And then the second part is using Visual Studio Code for a UI approach to Git. And also there's a couple of extensions I recommend, which I might demo if I have a bit of time at the end. These just make using Git a lot easier from your Visual Studio Code interface. Maybe just to explain as well, so Visual Studio Code is a development environment. So if you've used something like SQL Management Studio, it's quite similar in that sense, but it's more oriented around kind of software and data engineering development rather than just working with SQL. But I'll give a bit more of a demo of that during the demo. So going through kind of the Git workflow, and I can appreciate this slide is probably a little bit overwhelming when you first see it, but let me kind of try to walk through this. So I've kind of talked about how in Git there's a sense of a local copy or distributed copy you have, and also the remote repo. But on your local repo, there's actually a couple of layers that Git goes through. So let me kind of go through these A, B, C, D first, and then I'll go through the actual workflow itself on the left-hand side. So layer A is probably the easiest to understand. It's what Git calls the working tree. Effectively, it's just your local files. So if you save a particular file, or rather, I guess, add a new file or you modify a file that's in your Git repository, that's considered a change in your working tree, and that's picked up here. The next stage that you'd often go to is kind of a quasi-indexing or staging area. So this is where you're choosing which files you want to put into a given commit. So just to really quickly flash back for a second, what I'm talking about is these commits here across the lineage. So in the staging area here, you're choosing which files you want to add into your commit. So you may have actually made changes to 3 files, but you only want to commit 2 of them. So this is where you have control over that. I would say in practice, you're almost always committing all your changes. I'd say probably 95% of the time, if not more. But it's just worth knowing that this is something that actually does exist in Git, and there's a specific stage you have to go through, which I'll kind of show. The next stage is when you've actually made the commit itself locally. So this is where you have selected which files you want to stage and you have actually committed them. The next one here, so this one is, I think, one that a lot of people are not aware of. So there's your remote repository, which is what's stored on your remote server, your copy of your code base remotely. But locally, what Git actually does is keeps a copy of that for reference. But one thing you have to always remember to do, or usually have to remember to do, is you have to make sure that you pull in or you fetch in these changes to your local cache copy, because often you'll find a situation where somebody will start making a change from what they think is the latest version of the remote repository, but they haven't actually pulled it into here first. So this is just something to highlight. I think this will be a bit clearer once I get to the demo. So, oops, sorry, didn't mean to do that. Let me just reopen my slides for a second. Okay. So in terms of the actual workflow, so in terms of what you would actually do in Git, so you generally start off with cloning or pulling a repository. Cloning refers to actually taking a copy of your remote repository and cloning all the files, or I guess copying or synchronizing all the files locally. A pull is where you've already cloned it, but you just want to grab the latest version of it. Then ordinarily, so you're generally working on feature branches. You shouldn't be making changes to your main branch directly. So at that point, you need to actually either create a new feature branch for yourself or go into an existing feature branch that somebody else has created, or maybe you've been working on. After that, you make the changes that you want. So you're making the changes on your local files that I talked about. You then need to add your files to your staging area. So this area that I've talked about here. You then need to commit. Commit refers to making a commit locally here from B to C. You would then push your branch through from your local, I guess it's really your remote tracking, through to your remote repository here. At that point, you've made a change to a feature branch, and maybe you want to merge it to your central main branch. This is where you would raise a pull request. So this is probably a good time to talk about what a pull request is. So pushes and pulls, I think, are probably pretty intuitive to people. So a pull is you're thinking from the perspective of your local computer, and you're pulling in the changes, or you're pulling in your code base rather, from your remote repository. A push is very similar. You're pushing your feature branch out to your remote repository. A pull request is kind of a little bit of the reverse of that. So it's the way I would phrase it is you're making a request on behalf of the remote repository to make a pull activity from a particular feature branch that you've pushed into your remote repository. So you might kind of wonder why why the kind of gymnastics here around doing it in this particular fashion. The reason is you don't want people directly pushing, or developers rather, pushing directly to your main branch. You want to have more controls around that. And when you do these pull requests, one of the things you can configure on your server, let's say on GitHub or on Azure DevOps, is you can have mandatory reviewers of that, or certain procedures or even certain scripts that would run when that pull request happens. So you can automate a certain unit test, for example, or you can say that certain developers or a number of developers have to do a peer review and make sure this change is actually ready to be merged in. So it provides you a bit of comfort that you're not going to break your production code, essentially. So in the process of that, you may actually run into some merge conflicts. I'll talk about how to resolve that, but I'm just highlighting that's an activity you might have to do. Once all those conflicts have been done, you can complete your pull requests. You'll merge back into your main branch, and then effectively you begin again. So maybe there's a new change you need to make. So again, you pull in your changes, or you fetch your changes, and then you start this over again. So that's really, I would say, kind of at a theoretical level, probably really most of what you need to know to use Git at a basic level. But I will go through kind of some of the more advanced topics at a later point in time. So this is probably a good time to actually show what this looks like in practice. I think it's one thing to talk about it, and another to actually show it. So let me first do a demo where I will use the UI in Visual Studio Code, and then I'll do another one where I'll actually do it from the Git command line. So let me flick through to Visual Studio Code. So I have a demo kind of Git repository that I've set up. It's just very basic. It's a bunch of files I put in, really demo files more than anything else. One of them is just the SQL create table script. So just a very basic concept. Maybe actually just before I go into that, in case anyone is unfamiliar with Visual Studio Code, so there's really kind of three, I guess 4 sections here. Left-hand side here is your folder structure. So I've got a project here in a folder called webinar demo. These are all your different files. You can flick through your different files here and open them up here on the right-hand side. On the bottom right here, you've got your terminal. So this is where I'll show how to use Git from command line. And on the left-hand side here, you've also got your different extensions, and particularly your tab for version control. So I'll show this quite soon now on how to actually make commits using the UI. Just noticing we have a question in terms of Git versions, and if all the versions are pretty stable. I would say yes. I've never had an issue where I've had to roll back to a previous Git version. I think I've always just installed the latest version. So you should be safe to just grab the latest version. It's not something like Python where new versions of Python might break previous functionality. Git is generally pretty stable, so I wouldn't be too concerned about that. Okay, so let me just make a change and kind of show how this all works. So let's say I have this products table and I want to add a additional column of, let's call it SKU. It's let's say it's a varchar 500 column. So I'll modify this and I'll save it, and you'll see immediately that the change has been picked up in your version control. One thing I actually just forgot to mention is there are certain things you should do before you even start making that change. So as I kind of mentioned, you want to start with a git pull command. So this will just make sure that your branch is synchronized. You can also do it from the UI. So you can do a pull here. So this will do the exact same thing. It will just do it under the hood, essentially. You then want to check out the branch that you want to work on. So in this case, I'm in this feature branch that I'm using as an example here. So I'm just checked out here. Then you can make the change. So as I've kind of done here, once you've made the change, so you'll see if you click on this, it will highlight the change I've made. So this additional line that I've put in. And now let's say I want to commit it. So let me write a message. So added SKU column to products table, and then we can make a commit. So this has made the commit, but this hasn't yet pushed it to the remote repo. And then when we click sync changes, this will then do really it's doing a combination of pull and push, but just think of it as doing a push to your remote repository. So if I then tab to my remote repository, I've just set this up in Azure DevOps because it's probably the one I'm personally most familiar with. And you'll see here, there's a couple of menus here. One of them is branches. So the branch we just made the change to is this git p 103. And if I go into it, into history, you'll see this change has now been synced across, and you can see this change has come through. So that's kind of doing a change from the UI. It's probably the most easiest way to do it. But let me show how to do this just directly from command line. So one thing you generally want to do is you want to do a git status commands. Git status will tell you which branch you're on. So we're already in this branch, but if I wanted to change this branch, I would write git checkout, and I would name this branch here to check out into it. Here it pretty much tells me, hey, you're already on this branch. So now let's just make an additional change. Let's make this rename this column to, let's say, product description, just as an example. So rename. Actually, sorry, meant to be using the UI, the command line, sorry. So we've made this change. We can do another git status. So yes, it's kind of showing us here on the UI, but you can also use the command line interface here, and it will say, hey, you've modified this change, this file. I guess effectively, do you want to add it? So the way you can add it to your staging area is you can do git add dot. Git add dot basically says just add all your changes to your pending commit that you're about to make. And now we can do another git status, and now we'll say, okay, we've got a change that's in our staging, but it's pending to be committed essentially. And now we can do a commit. So we can do git commit. We write a message of updated product column name, let's just say. So this will do the actual commit here. You'll see it's committed here via the UI as well. And if we do another git status, so now we have a pending commit, and it's telling us to essentially do a git push. So we can do a git push, and that will push across to our repository. And if I go through back to Visual Studio Code, and I go to history, you'll see this change come through as well. So you might kind of ask, well, why am I showing this from command line when the UI is so easy to use? I would kind of mention that the UI does effectively sometimes bug out. So it is helpful to have an understanding from command line. And there's also things you really can't do from the user interface as easily as you can from command line. So it really does help to have a basic understanding of how this command line actually works. So great. So that's kind of a really high level demo of how to make changes using Git. So at this point, I might just jump into some more kind of advanced concepts. So branching strategies. So branching strategies relates to the essentially as somebody who's setting up a Git repository or managing it as let's say as a DevOps expert. What advice do you give, or what guidance do you give developers around how to actually structure their branches within the repository? So the one that I showed initially with just the two feature branches, I think on the first page, was kind of this structure here, which is referred to as trunk-based development. So trunk-based development is kind of functionally the simplest way I think you can set up branching structure. And it's actually probably the most common structure that's used in software engineering at the moment. The reason it works well for software engineering is a lot of changes, or a lot of code bases in software engineering tend to be what's called stateless architecture. So you're dealing with things like REST APIs, where you can give it a particular input, it will give an output, but it's not really concerned with managing data or through different layers or doing multiple layers of transformation. It's really kind of what are commonly referred to as kind of microservices or very decoupled bits of code. One of the nice things about that kind of software development is you can set up automated unit tests. So before you merge to master, you can actually run a whole bunch of tests on your functionality, make sure it's all working. And you can often do that without any actual human intervention. So this kind of leads to a situation where you don't need a lot of approval gates. You can release very frequently. And you don't need the complexity of kind of more layers of branches, essentially. But I guess when I describe this, if you're somebody who works on more the building data platforms or SQL or as a data engineer, you probably know this doesn't really reflect, I guess, how most data projects actually work. So in a lot of data projects, you have less frequent releases and they tend to be larger. And that's often unavoidable because you have to go through multiple layers of ingesting data, transforming data. You might be building a variety of different dimensions and facts in a data mart, for example. What that all kind of means is there's more complexity. There's often more approval gates as well. So you might have a technical sign-off. You might have different business teams that need to provide sign-off on a change that you're doing. And yeah, you're often moving data through different stages. So if you're familiar with the medallion architecture of going through a bronze, silver, gold layer, often that obviously has a lot more complexity in than let's say a REST API, for example. And the other thing is you generally need to do end-to-end testing. So with microservices or software engineering, you can run an individualized test for a single REST API or a single bit of functionality. But really to test data projects, you need to do an end-to-end test. So this idea that you can do a test right before you merge into master and you can run it quickly, I think is not really that feasible in data projects. So what that kind of entails is you end up with a branching strategy that's kind of close to or more similar to what's called a Git flow structure. So the Git flow structure is the one that's demonstrated here. I'll just do a quick run through of it here. Probably the main thing to highlight as a difference to the basic one here is, so you still have a master branch, which is your main branch for all your changes, but you also maintain what's called a develop branch. Developer branch is probably best thought of as changes from features that you're planning to release, which you've integrated together and you know are working in a non-production environment, but haven't yet gone to production, so haven't yet been merged into master. So this is kind of that situation I was talking about where you may have a lot of interrelated components of development, but maybe the business has not determined yet that they want to release it. So it's sitting in this pending area where it's functional, but it's not yet in production. In terms of feature branches, they really work very similarly to features branches off your master. The difference is you're kind of working off your develop branch here. The other aspect here is release branches. So especially in these kind of more complicated projects where you might have multiple features being merged into the develop, you often need kind of what's called a release branch. Think of a release branch as it's in a sense another feature branch, but it's focused on integration and making sure all the components of the code work together. So you'll often find individually features work, but when you combine it all together, actually there's a few things that need to be adjusted. This release branch kind of gives you a chance to do that before you raise a pull request to master, and this is where you would actually release your code to production. The other one here I haven't mentioned is a hotfix. So a hotfix is where you don't want to go through this formal process of going down to develop, through to feature, and back to master, because what's happened is you release something, but something has immediately broken in production. So you want to just fix it really quickly. You want to fix directly off master. You want to merge back into master with a pull request. So that's why there's kind of this expedited path here. But the key thing to call out here is you need to make sure to merge that hotfix back into your develop branch as well. Otherwise, you'll effectively be out of sync between master and develop. So hopefully that makes a little bit of sense. This is probably a complicated topic to really talk about and at a high level. One thing I would mention here is, personally, I found that a develop branch is actually somewhat redundant in a sense. So what I've described here is your typical Git flow structure. But in my personal opinion, I found that develop branch is to some extent a little bit redundant. What's usually more useful is just to create a release branch only from what's just about to be released. One problem you run into with this develop branch is that you might have two features which are finished off. You'll say, okay, great, I want to integrate it into develop. I want to make sure it's all working together. But then, the business will come back and say, actually, we don't want to release this first row of features. So the problem you're running into here is you've already merged it in to develop. You're going to have to pull it out before you can merge it back into master, because otherwise you'll also release the feature branch that you didn't want to. So this is kind of where I would subjectively suggest you may just want to create a release branch from your feature branches when you actually know you're ready to go to production, or when you know what features you really want to promote to production. So, and the other benefit of that is it just keeps things a little bit simpler. You avoid this whole layer of develop you have to worry about. The other thing I've highlighted here around Spectrum is what's appropriate to you or your team is really going to depend on a lot of factors. So how big is your team? How technically competent are your team? If they're very careful around how they test, do their tests and releases, potentially a trunk structure is simpler and a better approach. How many levels of approval do you have, or how complex is your code base? These are all factors that you can consider and kind of develop your own branching strategy. There's not really a one size fits all when it comes to this. Okay, so the other topics I'll quickly cover off on as well is naming conventions for branches. So this is something you also really want to establish upfront. So you might have a name of like master and develop, that's kind of your standard branches. But when it comes to things like features or bugs or releases, I'd recommend a structure similar to this, especially if you're using Jira. It can be really helpful to have the Jira ticket named directly in the feature. That means if you want to read the documentation about it or read all the kind of discussions that's happened around it, you can put this number to Jira and find all the details about it. You don't need to kind of be an expert on which feature relates to which one. Just releases as well. It's usually good to increment your releases as a version number as well. One thing I'll highlight here is branch names are case sensitive, so I would highly recommend just having everything in lowercase. You'll find if somebody checks in a capital feature, it's actually going to be a different branch, and you're going to be in a world of hurt trying to integrate those branches at some point in the future, because you'll have multiple people working on multiple sources of truth. The other topic I'll briefly cover off on is what's called gitignore. So Git has a special convention for ignoring certain files from your repository. So there's kind of a couple of situations I call out of where you might want to use this. So one example is maybe you don't want to check in. Well, you almost certainly don't want to check in your Power BI files into Git, but let's say you have them in your repository. If you put this into your gitignore file, which I'll show briefly, it will ignore any of these files from anywhere in your repository. Another example is you might want to ignore, this is something I use very often, you might want to ignore any folders which are called local. This is like a really nice convention often where you want to have at your disposal different variations of code that you're testing, and you don't want to have those be checked in. So let me just quickly jump to VS Code and kind of show what I mean here. So this is that gitignore that I'm talking about. And here you'll see I'm ignoring, what this means is ignoring any folders called local in any level of subdirectory in your structure. So you'll see here, I have a folder called local, and I've just put a file into here as an example. No matter what I do, let's just say I make a change here, it's not going to come through as a change because it's being ignored by Git. If I create a new file here, let's just say demo.sql, and I just put in anything in here again, it's not tracking it. So that's kind of the idea behind that. Let me just delete this here. But yeah, so maybe I'll just leave it at that. Another common use case is if you're using DBT for development, you'll need to have an environment file which has all your connection strings to your different databases, and you might also need a user-specific PAT token, as personal access token, to interface with certain tools. You can set it up so developers will have this env file which is specific to them, but that will never get checked in. So that's kind of another common use case for this gitignore as well. Okay. So next I'll talk about branch integrations. So this relates to particularly to do with pull requests, how you integrate your feature branches back into your main branch. So there's kind of, I guess, two types of integrations I would call out. One is where you're maintaining continuity with your branch, and another, which I'll show next slide, which is when you're breaking continuity. So git merge is probably the most common, really probably the only one I would recommend using as an integration strategy. Effectively, what happens when you do a merge is, let's say these blue commits here are from a feature branch, whereas this light blue is from your main branch. So what's happened here is you've got a feature branch with 3 commits, and then actually while you were working on that, somebody's actually committed another feature into the main branch, which has resulted in commits C and D. So now at this point, you want to merge in your feature branch back into the main branch here, which is your main line here. So when you do a git merge, what it will do is it will write a, I guess I don't know how to describe this, but a merge commit, which will effectively synchronize your 2 branches. So it will bring in all these changes, and it will bring them in as a new commit here. One thing that can also happen is sometimes it doesn't actually need to make this additional commit. If there hasn't been any other changes on your main branch since you created your feature branch, what Git can do is called a fast forward. Fast forward will just bring in effectively E and F into your, well, to use this example here to avoid confusion, D and E into your target branch, which is your main branch, and it will avoid creating this additional, I guess, merge commit branch. Not something you really need to worry about too much, but if you find this terminology, this might just clarify what that means. Just to add an additional clarification here. So this is shown as a git merge, but in practice, usually the way that you use this is through pull requests. A pull request under the hood will give you the option of doing a merge or another integration strategy. So while this is saying git merge, just think of this as actually the pull request that's doing this activity. And then I guess this is where I'll cover the branching strategies without branch continuity. First one I'll cover off is squash. So you can add this modifier to merge. What squash will do is, rather than bringing through all your changes as individual commits, you'll actually squash all your commits down to a single commit, which you can see here. And it'll essentially compact them all into a single commit. So this, the most common situation where you use this is where you're merging a feature branch, probably say, possibly into main, but let's say into develop branch. But in that feature branch, you've kind of done a lot of changes. You've changed one thing, you reverted it, you've changed it again, and you just created a bit of a mess in terms of commits. You don't want to preserve that history because that's going to be a pain to go through if anybody needs to find where there's a bug in that. So one thing you can do is you can squash it all down to a single commit. So this just makes your lineage on your main branch much simpler to manage. But one thing I really want to stress here is to be careful about this is, while this is fine for feature branches where you merge it in and then you're immediately deleting the feature branch, what you really want to avoid is a situation where you've squashed in a main branch, and then you want to I guess pull that or merge that main branch back into an unsquashed ancestor in the future. So that might be a little bit abstract, but I guess the way to think about it is, when you've squashed changes in, you've broken the lineage potentially to some of those commits. So the ancestor branch, which has all your individual commits, when you try to integrate your squashed commit branch, there basically won't be any lineage, because the squash only exists in the branch that you're grabbing from. whereas in your ancestor, you had all your individual commits. So basically, Git will throw up its hands and say, I don't know how to integrate this, and it will give you a whole bunch of merge conflicts to deal with. So just be very careful about that. I just use this as a guidance. Just be careful about squashing where you're going to pull from that branch in the future. The other one I'll briefly touch on, which is a little bit more abstract and is less frequently used, is something called Git rebase. So what Git rebase does is it's an alternative way of merging, where rather than kind of having this merge commit that I showed earlier, what Git will do is kind of rewrite, and when it merges into main, it will rewrite all your feature branches as if they had occurred immediately when you merge or your Git rebase activity happens. So this will also rewrite your history, which again, you need to be very careful about, because if you try to integrate the non-rebased version, you're gonna have trouble. In short, I would generally avoid this unless you really know what you're doing or you have a very high preference for this. To me, this usually adds more confusion than it actually helps to solve. Okay. Just had a comment in the chat around the new Power BI format for source control. Yeah, that's a really good call out. So there's a new Power BI format called PBIP, which effectively, so usually the typical Power BI files are PBIX files. PBIX files are essentially zipped files of your Power BI metadata. But the problem with that is Git is very bad at version controlling them, because each time you update a PBIX file, it recompiles it, and Git has no way of tracking changes over time to that file. So I kind of won't talk too much about it, but if you're interested in version controlling Power BI files, have a look at Power BI projects PBIP format. It's quite helpful. I think there's also been I might come back to this at a later point in time. Okay, so merge conflicts. So this is kind of the last section I'll go through. So merge conflicts occur in Git when Git can't determine which branch commit to use for a particular line of change. So it's very easy to think of a merge conflict as two people modifying the same file, which kind of is true, but it's very specifically where it doesn't know the order of those changes. So if you modify a file, commit it, modify a file again, and commit it, that's completely fine. But if you modify the same file from the same commit in different commits, let's say in different feature branches, you're going to have a problem, because Git doesn't really know which one to use. That's kind of where I mean, where there's the same parent, but changes are made concurrently. It can also happen if you lose your ancestry. So that what I talked about around squashes and rebases can also cause merge conflicts. So it can occur in a whole bunch of different situations. Probably the most common, the one that people get most confused by, is pull requests. So this is the one I'm going to demonstrate. And let me just show, just as a diagram, kind of what this actually looks like. So I've kind of already talked about the situation that causes this. So you'll have, let's say, Alice commits from commit A to B, but then you'll have Bob who commits also from state 8, but to commit C on the same file on the same line. So the way you would usually resolve this, actually, let me take a step back. So the key point here to highlight when it comes to resolving this for pull requests is most likely this commit from A to B has already been merged into your main branch. And then what's happening is, somebody's bringing in a different feature. The feature is a change from A to C, and they're trying to do a pull request to pull their change into the main branch, which already contains this change here. So hopefully that makes a little bit of sense. It can be a little bit hard to follow, but I'll show a demonstration after. So what you want to do, because at this point, the change from 1 is already in your main branch. You can't alter history, or you shouldn't be altering history in your Git lineage. So what you need to do as the person with this feature branch from commit from A to C is you need to pull in this change from A to B, and then effectively make your change on top of B through to C. And that's what resolves the conflict, because you've now created a lineage that Git can understand and an ordering that it can figure out in terms of how to merge. So let me do a demo of this, and hoping I have enough time to go through. Yep, I think I should be fine. So, okay. So we're currently in this branch git p103. So let me switch over to 104. So git checkout this branch, and you'll see here once I switch through, this change that we previously did has gone. The reason for this is this branch is based on the previous, 104 is based on the previous version without the commits we put into 103. So let's say I make a change here, changing the varchar type of this description column, and let's say I also rename this to, let's say, product description, for example. Let me make this commit. I'll just call this change product description name type. Name type. So let me commit this and I'll push this through. So now, sorry, let me just show you this synchronizing. So this will push to your remote repository. Okay, that's done. And now let's raise a pull request where we want to merge this new change that's come in into main. So ordinarily you'd have reviewers here, but just in the interest of time, I'm going to skip that. And actually, I've just realized that I haven't actually merged this previous change in either. So let me first do a pull request for the previous change that we talked about. So 103. So let me just call this, just for simplicity, previous change. So we'll merge in the previous change. So as I mentioned, usually it'd have a previous here, but I'm just going to skip through this because this is just a demo. And so let me merge this in. And now that we've merged the previous change that we did earlier, let's now merge this new change that we've just created before. So let's merge in 104 into main. Let's create a pull request. And hey, okay, we've got a merge conflicts. So this is kind of the issue I've highlighted where we've changed the same line, and therefore Git is saying, hey, I don't know which one to use, essentially. So the way that we resolve this is first we do a git pull. So we resynchronize back to our remote repository. We then need to modify this branch that we're working on. So remember, the main branch has already had the pull request from 103, and we can't modify that, but we can modify 104 to create lineage such that we can merge our new change into main. So let me make sure that I've got this branch checked out. Let me just do another pull just to make sense and make sure. Okay, and let's do a merge in of this change from 103 from main into our branch. So I'll do merge main. Okay, so so I actually first need to check out main and I need to git pull. So the reason nothing happened is my main branch wasn't synchronized up to my remote repository. So now that it is, I can go back to checkout this branch that we're working on, and now I can do a git merge main. So this is now showing us actual conflict. So you'll see what's happened here is Git has put in these kind of brackets here of current change and incoming change. So you might be wondering, is this actually in the file itself? And yes, it is. So one thing you want to be really careful about with merges is if you're in the middle of a merge, you need to actually either abort it or you need to resolve it. You can't keep it as is, because if you commit this is obviously going to break whatever code you're running, because this is not going to be valid code, essentially. So what Git is kind of showing you here is these are the two conflicting changes. So we've changed the name in both, but one of them has a change of the varchar type, whereas the other one doesn't. And Git's kind of saying, I don't know which one I want to use. So in the UI, there's actually a couple of nice ways you can resolve this. There's a resolve in merge editor option here. This will give you the comparisons of what the different changes are. So you'll see the 100 versus 400, and you can choose to go with either one or the other. So let's say we go with this one, for example. This will update it with this version essentially, and then you see now that the merge has been resolved. Let me actually undo this and go back to the previous state here. So you can also just directly resolve it yourself. So if, for example, you just remove these lines and you know that this is the state of your actual code that you want, you can just essentially remove these lines, delete them, and resolve it this way. So just kind of show there's all these UI features, you can kind of explore them yourselves. They do make things a lot easier in terms of picking and choosing which one to use, especially when you have a lot of merge conflicts. But at the end of the day, this is a text file. You can modify the text file and fix it up. So now that we've done this, we can do, sorry. Now that we've saved this, what we can do is we can add these files in again. So we can do an add dot. So this is now, you'll see this has changed from merge conflicts, I believe, to stage changes. And then we can do a commit. So let's just call it this. So now we're committing the resolve change, and we can push it through back to our remote repository. So again, I'll do the push through with the UI. And if we flick back now to our pull request, once this is finished running, so you'll now see in our pull request, this active one that we have here, it's now saying that there's no merge conflicts. So we've resolved the lineage issue that we previously had before by effectively bringing in the previous change that we were missing from our feature branch and then putting our change on top, which is now kind of resolving the lineage issue that Git had before. So that's kind of your high-level view of merge conflicts. If there's any questions, I might have run through this a little bit quickly in the interest of time, but if there's any questions, I'm happy to answer them at the end as well. Just before we finish up and go to Q&A, I've got a bit of a slide of best practices. I might just run through this really quickly and highlight some of the things we talked about. So make sure you pull in changes from your origin before you make changes. This was actually highlighted by me having to do this for the main branch. So because I didn't do that, I wasn't able to resolve the merge conflict unless I'd done that. Write meaningful commits. So with meaningful commits, it makes it easy to figure out what a change was if you ever need to debug it in the future. You generally want to split your changes into atomic commits. This again makes it easy to revert things if you need to by an individual commit. So we talked about squashes. Might skip through a couple of these. So code reviews. So code reviews is something I, again, skipped over, but as part of a pull request, you really should have one or ideally two developers review code. And it can be a really good practice to have developers highlight kind of improvements that can be done or breaking changes, of course, as well that need to be reviewed before that merge can be completed. We talked about branch name conventions. One thing I'll very quickly touch on is tagging. So one nice thing that you can do in DevOps, and I think a lot of other tools as well, is you can tag a particular commit that relates to a particular release. Let's say this is release 1. Let me just say 1.1. So this is kind of tagging that a particular point in time on the main branch is release 1.1. And once I've done this tag, you'll see that if I go into the main branch, into history, you'll see there's a tag here. So this makes it much easier if you end up doing a lot of releases to figure out what commit actually relates to when you promoted something or you deployed something to production. So that's tags very briefly. Commit stash changes, I might skip through that. So we talked a little bit about not including binary files. So Git is not good at tracking binary files because binary files are recompiled each time you create them. So you generally want to exclude them. So something like a PBIX Power BI file, you want to include that in gitignore. You don't want to commit that. You also, in general, don't want to commit big files because of the way that Git is designed around distributed code bases. You're basically forcing everyone to download those files each time that they pull from the remote repository. Some of these other ones we talked about. Not rewriting history is also a really important one. So there's a command called git revert. What git revert does is it doesn't actually erase your commit. It creates a commit which reverts whatever you're specifying that you want to revert. So this is just something you want to keep in mind. If you do change your history, anybody who's dependent on that ancestor commit that you've deleted is going to have a break in their continuity and going to have merge conflicts as a result. Another one I'd highlight is VS Code has tools which allow you to auto format. So this is actually not configured correctly, but so some of these, there's extensions you can put in which will format, for example, your SQL code in a good fashion. You want to be careful about this because when you do this on a file, you're effectively changing every single line. So from code-based tracking perspective, it's going to make it a little bit harder to see what was the actual change versus what was the reformatting that's happened. Another really big one is don't commit passwords to repository. So you generally want to use secret references. So when I say secrets, if you're familiar with something like Azure, there's a tool called Azure Key Vault where you can store the secrets in your key vault, and then you can have your applications reference that key vault and not actually expose your secrets directly in your repository. So the issue, of course, is that if it's in your repository, then anyone who has access to it knows your secret passwords, which you don't want to happen. Okay, so just in the interest of time, since we've only got 2 minutes left, I do have a bunch of appendix slides, and what I might do is see if we can share these the slide pack with attendees. So this is a bit of a summary of what I've talked about. There's a few other commands that I didn't have time to go through. Particularly these ones here, there's a couple of more advanced commands you might want to use. But I guess in the interest of time, I might go to Q&A. Were there any questions or comments? Just having a look at previous comments. So Jeff has mentioned there's example of branch naming conventions. So I might just open this up. So I think this is what GitHub recommends. So this is a great. I think I've seen this before as well. This is a great guide. Maybe we can share this as well as a link if you want to also have a look at this. I would also point out, I think Atlassian has a lot of very good documentation around using Git. So if you particularly Git flow, I think it does a very good job of explaining it. I would highly recommend if you want further information, have a look at their documentation around that. Okay. I guess if there's no other questions, then we're at 1 p.m. on the dot. So thanks about the memes. So I guess we'll finish off now. Yeah, feel free to reach out if there's any other questions. I'm happy to answer. Great. Thanks.